So this is going to walk through the transformations of quadratic functions using vertex form. To really show these transformations, I'm going to work through this Desmos activity. So we're going to start by identifying the parent function of quadratics. Remember that a parent function is the most basic form of any function. So for quadratic functions, that equation would be, y equals x squared. It has no a value, or a is 1. It doesn't have an h or a k value. It is the simplest form of any quadratic function. And we're going to look at how we can transform this really simplistic quadratic function into different versions. So the first thing we want to look at is what happens if we change the value of a. So you can see here that there's 3 equations on the left side, and the first one is the parent function y equals x squared. I'm going to go ahead and turn on y equals 2x squared and compare that to the x squared line. You can see that it is moving up at a faster rate because that a value is 2. If I turn this one on, now you can really see that the acceleration of the line is much faster, and so we would call this a stretch. Basically, if a is greater than 1, it's going to increase faster than the parent function, and so we would say it is being vertically stretched, meaning that it is moving up vertically faster than the parent function. On the flip side of that, if we have values of a that are not greater than 1, like 1/2, you can see that this orange line is now below the green line, and 1/5 x squared is even lower than that. So when you have an a value that's less than 1, it's going to cause the line to move or to increase more slowly, and so we would call this a vertical compression, meaning that when we say compress, it's not moving as quickly up the vertical axis, so the function, the y value, is not increasing as quickly. So not only is a responsible for how quickly the graph moves up or down the y-axis, it is also responsible for whether it is going to be moving up or down. So if we have y equals 2x squared, this graph is being stretched from the parent function of x squared because it's being multiplied by 2. However, if I change it to -2, it's going to cause it to reflect over the x-axis. So it's still being vertically stretched at -2, but it's now also being reflected, so it is still moving faster than the parent function, but in the opposite direction. So the same thing would be true if it was 1/2 x squared. This would be a vertical compression. It is not moving as quickly as the parent function. If I change it to -1/2 x squared, it's still moving less quickly than the parent function, but it's moving in the opposite direction. So a causes it to vertically stretch if it has an absolute value greater than 1, or vertically compress if the absolute value of a is between 0 and 1, and it will cause it to reflect if a is a negative value. Now here we're going to explore what happens when we change the value of k. These equations on the left do have a value of k and not h because the value is not inside the parentheses with x. So the binomial itself is not being squared, so this is a value of k. It is outside of the parentheses. In the equation for vertex form at the top of the screen there, you can see it's a plus k, which means that the equation already has addition, so whatever k is will be reflected truly in that equation. So if it's plus 3, then you can see here that the whole line shifts up vertically 3 units. If it's plus 5, it shifts up 5 units because k is positive 5 or positive 3, which is reflected from the equation. If it's minus 2, then it shifts the line down 2 units. So k is the vertical translation, and it will do exactly what it looks like. So k will shift up when it's positive and down when it's negative. Now here we're going to look at what happens with h. In the equation for vertex form, it is minus h. That means if you are still seeing minus h in the equation, that the h was positive and it did not change subtraction over. If it has switched over and says x plus h, that means that h had to have been a negative value to create the situation where you would have minus a negative, which can be simplified as plus a positive. So if you're seeing it switch over to positive, that is because the h itself was negative. So if we're looking here at minus 3, this is going to be our horizontal translation. You might think that minus 3 is going to cause it to move to the left because we think minus moves to the left. But remember, we are minus a positive 3, so let's see what happens. So you can see with the purple line that it did not move to the left, it actually moved to the right. And that is because that 3 is actually a positive 3, since the formula already included the minus. If we're seeing it as plus 3, that means it was originally minus a negative 3, so we can see that that one would move to the left. So these are a little trickier than k, because you do have to kind of think about, oh, it was subtraction. It's going to be the opposite of what it looks like when it's inside of this parentheses as h. So now we're going to do the whole shebang. We're going to put all of them together. This is a great chance to pause, see what you think the equation would be for this transformation, and then check in a moment. So the transformation is that we want to write the equation that will shift the parent function to the left 2 units. So left and right, that's your h value, h for horizontal, if that helps. Up 5 units, that's going to be our k value. Stretch the parabola by a factor of 3, so that's a, and reflect it over the x-axis. So we're going to say y equals. I'm going to start with that first thing. It's going to shift to the left 2 units. So x should be minus. If I want to go to the left, it would be minus negative, which is weird. So I don't want to write it that way. I want to switch it from minus 2 plus 2. Close those parentheses and square it. So now I've done the first transformation. I have shifted it to the left 2 units. I also want to shift it up 5 units. So to do that translation, I just need to make k a positive 5. It's already addition, so plus 5. So now we went to the left 2 and up 5. If I'm going to stretch it by a scale factor of 3, that's our a value. So let me go back to the beginning. A scale factor of 3 means that it's going to be stretched vertically. It's going to look thinner because it's moving faster. And then it is also reflected. Okay, so that means it's not just 3. It should be negative 3 to cause it to reflect. So that should take care of all 4 of those transformations. And we can look here on the next screen, and it does match. If it didn't match, you would see another line where ours should be. So here we'll just recap what the 3 parts of the equation in vertex form do. So what does a do, what does h, and what does k do as far as the way it moves the graph. So for a, what values of a will create a graph that opens up? Graphs that opens up must have an a value that is greater than 0. That means the a value must be positive. In order for the graph to open down to be reflected, a should be less than 0, or a should be negative. A vertical stretch will happen when the absolute value of a is greater than 1. So if you're multiplying by a number greater than 1, you'll move faster. And a vertical compression will happen when the absolute value of a is less than 1, and I'm going to say greater than 0, so somewhere between 0 and 1 as absolute value, meaning that you're multiplying by a number less than 1, it's going to cause it to move at a slower rate. Now your vertical translation, that's your k value. The graph will shift upward when k is positive. So when k is greater than 0. And it will shift down when k is less than 0. So when k is negative at the end of the equation, if you have minus, then that means your graph is going to shift down. A horizontal translation, these are going to be the tricky ones, right? Because it's already subtraction. But it will still shift to the left when h is less than 0 or when h is negative. However, that means it's going to look like plus, right? So it's going to look like a plus h squared. So when it looks like addition, it's actually going to be moving to the left, and that's because it was really minus negative h, and we rewrote it as plus. Same thing for shifting to the right. Not right that way, but, right. If h is greater than 0, then it will shift to the right. That means in the equation, it's going to stay subtraction because h is a positive and it's not going to change subtraction over to addition. So the horizontal translations are a little trickier, but I hope that is enough explanation for you to kind of understand.